Hi everyone. Thanks for coming. Thanks for coming to my talk, and thanks for coming to Unite. It's a real honour. This talk's about audio. I always suck at titles, so I just made the most stupid one. A little bit about me. I work at Unity, obviously. I work in the R&D core. I moved to Copenhagen from Australia, actually Melbourne, a few years ago, and I've been working for Unity ever since. And here's a picture of me trekking along the Great Wall of China. That's kind of some of the cool stuff we get to do if working at Unity. I guess this talks a little bit about the future of audio in Unity. And as you kind of got the picture from the keynote, if you went, it's all about more. We're definitely pushing audio in Unity a lot more now, and we're going to be releasing more and more tools for you guys in the future, and some really cool stuff's coming up. So, to get started with all of this cool stuff, we actually had to take a step back and evaluate what was going on in audio at the currently, I guess. And I guess the big issue was that the current system had its limitations or whatever, so we had to take a step back and build a solid framework. We had to rewrite the whole asset pipeline, the way we actually manage resources, and all sorts of other stuff like that. Basically, that's kind of clearing out a lot of the missing features and clearing out a lot of the bugs that we had, which was obviously super important. And so from then, we actually have to make better workflows. And I'm going to talk about a few of those today. So, what's next? So, I guess after we finished sort of cleaning up the back end of the audio in Unity, we actually had to sort of come up with something that we wanted to give you guys that was really cool and shows that we're serious about audio. So who's a sound designer here? Anyone? 2 sound designers, 3 sound, 4 sound. Okay, so not many sound designers, but basically we want to create tools in Unity that even anyone can come along and use. So whether you're just a general programmer, you're making your own game and the whole thing in it, or you're a dedicated sound designer, we want to build tools that is flexible and usable by everyone. And we want to create tools that will allow you to kind of use the full spectrum, mind the pun, of all of the sort of ideas and sort of creative inspiration that you guys will come up with. So to begin with, I'm going to talk about the audio mixer, and then from there I'm going to talk about some other kind of more low-level improvements. So firstly, why the audio mixer at all? So I guess the first and easiest way to answer that is that there was no actual way to mix before in Unity. You were able to play through audio sources, and they were played into the audio listener, and there was nothing in between. You could have effects on either one of them, but not on groups of them or anything like that. And we wanted to create something that, again, is sound designer friendly. It's got if you've seen a digital audio workstation, you'll be familiar with it, and hopefully be able to pick it up pretty quickly. And also because getting the levels of audio in games getting the levels of audio in games correct is actually really important, and having a consistent mix across the whole game is actually really important. So first I want to talk about categorizing sounds. So I guess a lot of sound designers will know that you actually want to play sounds and you want to group them together, and you want to do things to those groups, and you want to have them kind of be affected in similar ways, and you want to construct hierarchies of those groups and sort of apply effects, volume adjustments, pitch adjustments, things like that. And categories can be anything. I mean, every game is different, and every game has different categories, whether they're based on different levels or parts of the level or things in the level. I've got an example here of a game that I just am making, I guess. And it's got some simple categories, everything from weapons to music scenes, to ambiences and stuff like that. So yeah, as I said, categories can be anything. And this is obviously the purpose of the audio mixer. And what it is a new type of asset, so you can actually drop it in like a material or something like that. Drop it into the project browser and then start editing in Unity your mix. And it allows you to create some pretty awesome sort of routing configurations. Here's an example of how it kind of works under the hood. So you have your audio source in orange and your audio mixers, and they're constructed with audio groups, and everything kind of mixes together. You can actually have audio mixers play into other audio mixers, into an audio listener. So you can actually create really complex kind of hierarchy configurations. You can swap and change them out and do some interesting things there. And basically the audio mixer, for those who are not kind of familiar with audio, the audio mixer is about the global mix. So it's about controlling the overall mix of the entire landscape. It's not about interactive sounds. I'll talk about interactive sounds later on, but it's about controlling kind of the whole soundscape in one go. So what I'll do first is I'm going to actually create one from scratch. I have one in front of us here. It has a bunch of audio groups in it. But what I'm going to do is I'm going to create a new one, just to give you an idea of how you would construct one and set one up. I just have to lean down because this table's for midgets. So if I jump into the game, you'll see that we've got an ambience, sort of bunch of ambient sounds playing, but they're not really mixed that well. So what we'll do instead is we'll create a new audio mixer and just call it, spelled it wrong, but I won't. And I'm going to put it into the main mix. I'm going to actually route it into the mixer that I've already got, into the main mix, into the Foley audio group. And from there, what I'm going to actually do is I'm going to create a bunch of groups for the different ambiences that are playing. So I'll create one for birds, and it's for crickets, and for frogs, and just a general ambience. And from there, I can actually simply start assigning these groups. You actually route from the audio source. Now there's a new field called output. And crickets, frogs, and ambience. Now if I jump into the game, we should start seeing some levels. I can immediately go in and start playing with the mix and try and get something that sounds a little bit better. So we'll bring down the mix, make it a bit more background. Birds are a little bit loud and the frogs, yeah, that makes more sense. Okay, so now we have something that sounds a little bit better. And as you can see, when I leave play mode, actually it persists all of the values, so you can actually start editing during play mode, and you actually can construct your mixer as you're going. You can add effects and do all those sorts of things, and it'll all persist as you're going along. So, but obviously it's more than just setting up sort of mixing hierarchies and setting levels. So one of the things that you can do in Unity is add DSP effects anywhere in the mix. So the great thing about that is before, if you had DSP effects on all of your audio sources, they were actually separate DSP effects that were being applied one after the other. But with this, obviously, if you're applying a DSP effect on the master group, it's all of the signals being mixed together first, and then you're applying it once, which is great. Attenuation is applied anywhere where you place it. So actually, if you have a look back here, you can actually choose to apply the attenuation in any audio group anywhere you want. So you can just drag it up to the top or down to the bottom. And the actual volume here shown here is the volume that's actually at that point in the mix. So you can also use this attenuation as a debug mechanism to see what your levels are like as you're going through the audio group. And to demonstrate that, what I'm going to do is I'm going to add a reverb to my mix. Perhaps what I'll do is I'll apply it to the frogs, because they live in caves, I guess, and they need reverb. So what I'll do is I'll add a new. No, what I'll do, I'll actually just add it to the group, and you can see here that the effects are shown in the inspector. And if we jump in here now, we can start playing with the different and get a little bit of sort of a reverby effect on the frogs, which will come into play later. Okay, so but what about if the effect that you want is actually not in the list of default effects that we give you? And one of the great things for Unity beforehand was that you were able to do this with the on-audio filter read in mono behavior. So you're able to actually do a lot of signal processing yourselves in script, which is great. But on the other hand, you couldn't do anything really complex because it was also very CPU intensive. So now we've created a new framework to allow you to do custom DSP plugins. So you'll be able to write your own custom plugins in C++ or whatever you like, create a DLL, drop it into Unity, and then actually be able to drop those effects into the mixer straight away. And one of the great things about it as well is you can actually start drawing your own UIs. So we have the ability and the framework to construct your own visualization of your effect here, and you'll be able to draw whatever you like there and see exactly what's going on in the mix. So I'll just show you quickly how that works. We've got an interface here, which is the interface that you're basically extending. It's very simple, and it's just a bunch of callbacks that you have to implement in your DLL. And as an example, we have a loudness meter here. So not all effects have to be necessarily affecting the signal. They can also do analyzing the signal or things like that. And here's just the example GUI that you would have to write, you could write to display the loudness meter. So let's actually just drop that in, and let me just check what's going on. Let's try again. Jump in here. Numbers aren't not showing. It's weird. Let's try a different effect then. You can have any sort of effects that you want. For example, we have an example multiband compressor here. Or in fact, even like things like vocoders, convolution reverbs, things like that. So if you want to throw in a convolution reverb and get some kind of interesting effects there. But yeah, so that's custom plugins, which is really awesome. And it's going to allow you to do some pretty awesome things. You can imagine if you're a DSP manufacturer, you can start developing awesome DSP, put it on the asset store, make some money. You can also obviously get some awesome effects and plugins from other distributors. if you're not into audio yourself. So there's a lot of things a lot of places where this can go. So next I want to talk about immersion. So as I said before, the mix and the global mix is really important. But what if you want to not just have a static mix? You want to transition between the moods and the themes within your game as you're transitioning as the game progresses along. And this is like super powerful. You can introduce new stems, as I did earlier on in the keynote, into the mix, or you can change sort of environments as you're traveling around the map if you want to do zone-based transitions. So again, let's jump in here and let's start introducing some snapshots into this ambience. Actually, let me just... I have an example here that I made up quickly. Basically, it's my zone-based kind of approach where I want to have sort of an eerie mood in the forest, and sort of I want to introduce maybe some music and sort of more excited stems in the tavern. And we want the dark sinister kind of appeal in the cave. But here in my game, what I'm going to do is I'm going to actually change the characteristics of the sound based on whether I'm inside or outside this little area here. I have a trigger here around this area, and I've written a little script that basically just activates these different snapshots. So I'm just going to add them. So we'll go inside, and we'll call this one outside. Oop. And we'll say that inside we want the ambience to be ducked a little bit. But actually, let's jump into the game. Actually, let's set these guys up. Inside and outside. Let's jump into the game. And if we go through the portal, we'll see that we're in a different sort of environment. And we can actually maybe edit that snapshot as we're going along, and we can bring that back up a bit, but we're going to bring down everything else and bring the frogs back in. Now when I exit, we just have the frogs. So that's what you can kind of, a very simple use case of snapshots. And basically, these guys can capture any of the parameters within your mixer. So I'm not just talking about volume or pitch settings. I'm talking about any of the parameters within an effect. We also have the ability to bypass or add a dry channel around an effect, and you can snapshot that, which is pretty powerful because then you can start introducing and taking out effects as you're going along through the game. You can snapshot sends and returns, which I'll talk about later. And yeah, there's a whole bunch of stuff that you can do. But what if you want to not just have a traditional sort of tree of signal flow? What if you want to branch the signal? What if you want to send a portion of the signal over somewhere else and do some processing and then mix it back in? Or what if you want to actually use signal from somewhere else in the mix to change properties of how you process signal over here? And that's something that we can do now in Unity. And I'll talk briefly about each component that you can add, and then I'll talk about how you can extend this yourself. So sends. Sends are quite simple. What I'll do is I'll actually get rid of this guy and remove this effect. I'm going to add a new group, which I'll call reverb. And I'll add a send. But at the moment, I can't really send it anywhere. So what I'll do is I'll go back here, and I'll talk about receives. And receives are kind of like the sink of a send. If I branch some of the signal, as you saw here, if I branch the signal at this send, I need somewhere to put it. And the simplest case is to just mix it in somewhere else, and that is what a receive is. So what I'll go and do is jump in here, add a receive. put it before the attenuation, and then I'm going to send to that guy, and I'm going to send, I'll send the whole lot, or close to the whole lot, across. And when I say send it, I'm not saying I'm removing it from the mix. I'm actually sort of creating a copy, or so diverging the signal. So now if I jump back into the game, you'll see that I'm actually sending it over here. And if I, to show you that it's actually going in and being mixed at that point, anywhere in the chain, I can just drag that under there and you'll see that there's no signal coming through anymore, because it's actually being mixed after the attenuation slot. So that's receives. And we also have the concept of duck volume. And what duck volume is like a sidechain compressor. It allows you to send a portion of your mix to somewhere else and have that affect the mix or affect the volume somewhere else. So I've got an example here of how that would work. I have a bunch of duck volumes here. And what I'll do is I'll actually show you with music how you can sort of compress perhaps the main portion of the mix with a kick. And I'll jump into the world. And if I jump in, you'll see we've got a kick. But at the moment we're not actually compressing at all. We're sending from the kick over to the main pad. We're not compressing. So what I'll do instead is I'll jump in here. And as you can see, we're kind of punching the main pad with the kick, and it gives that sort of more sort of punchy characteristics. Anyway, so you can start seeing like where you can take this with some of the ideas. You can start sort of combining different sends, returns, duck volumes, things like that. But what we also actually do is allow you guys to write your own kind of sidechain logic. In the DSP plugin system, we actually, if you ask for a sidechain buffer, you then become a sort of a send target. Allowing you to receive sidechain buffers from a send, and then you can do any sort of processing you want. You can use it to create your own compressor or vocoder or something like that. So yeah, it's pretty cool the things you can do with the new DSP plugin system. Cool. So now I want to talk briefly about core improvements. These are the things that you probably don't really care about as much, but they're also important because it means you're going to be able to scale your games and scale the audio within your games a lot more. And to do that, we actually had to take the approach that it's all about the data. It's about the types of data that we use, or the types of data that we sort of compress to. It's the transformation of that data, so how we actually transform that data from the source data that you import, how we fetch the data during runtime, how we control the lifetime of the resources, and how users interact with it. So we have this new, I guess, asset pipeline, which I'll show you actually. Easiest just to show you. We have, I just select a clip. We now have the ability to, obviously force to mono, we have the ability to load in background, which means that your scene won't block as you load it. It won't block by loading all of the data at once, it can just load in the background. And this, coupled with preload audio data, is actually very important. So now in Unity we've separated the data from the actual kind of scene load. It sits in a separate file. And what that means is that you guys can come along and say, I don't want to load this audio clip when the scene loads. I want to take full control of the lifetime of the audio. And there's an API that basically you just say load data and unload data, and it allows you to create your own loading strategies, which is super important. And what we've also got is the ability to do different compression. Well, I guess these guys you've already seen, the decompress on load, compress in memory, and streaming. We've added a whole different bunch of formats, and we now let you choose whether you want to use Vorbis compression, 80pcm, MP3, depending on what you want to do. So 80pcm, it's a cheap codec, but you have noise characteristics, especially in high frequencies. If it's like a noisy kind of source that you want to play, then it's a great choice. Vorbis or MP3. MP3, I guess, is not the greatest choice, but we're going to put it in there, or maybe we'll take it out, we're not sure. Depending on if it's overused or abused, I guess. And then, obviously, if you choose one, you can change the quality settings. You can optimize the sample rate now. So basically, when you import a new clip, we can take over and analyze the clip itself and create a sort of a more optimized sample rate to give you the best quality and the best sample rate characteristics. Or you can actually override and select whatever sample rate you want, and it'll re-encode it to that sample rate. And this is good for if you want to match the sample rate to the platform. And talking about platforms, we actually have, just like textures, we have platform overrides now. So if you want to have, for example, on your mobile builds, you want to have it's streaming instead of loaded into memory because of memory RAM budgets or whatever. You can do that. You can change the compression format or whatever, which is pretty cool. And one of the awesome things that we've kind of gone ahead and done, which was an annoyance for everyone, is we allow multi-clip editing. So basically you can go in and change the characteristics of a bunch of clips at once, which is super important. And we use a new container format. So before, for example, with OGG, we used OGG Vorbis. We got rid of that, and we use fmod's FSB format. And that means that the memory characteristics used by Vorbis is a lot lower, and it's just a much more lightweight and compact container format. And here's some characteristics. We did some analysis. The top one is MP3. The middle one is for the new Vorbis compression using FSB. It's much better memory usage in compressed in memory and things like that. And we also have OGG Vorbis, which of course is crazy memory usage. So transforming the data. We've created an import pipeline now that actually offboards the encoding. So if you import a buggy or a corrupted audio clip now, it's not going to crash Unity. It's just going to crash the little tool that we created that runs in the background. This is obviously hidden from you guys. You don't need to worry about that, but it just means that it'll be a lot more stable. We have much better support for large files. So this tool can handle any sized audio input now. And like I said before, we separate the audio data from the actual scene data, which allows you to go in and load it or unload it whenever you want. We have much better streaming now. Before we had really sort of, I guess, undesirable streaming characteristics, and we hogged file handles a lot. But we cleaned that up. We actually only ever go above a handful of file handles now, even if you've got a bunch of streams running using a virtual file system. And we do async loading, as you saw. And we, like I said, the lifetime of the data. So we preload. Or delay the loading, as you saw. I showed you before. We have you can do custom loading strategies, and like I said, it's something that allows you guys to have a whole bunch of audio clips in your scene. Before you were kind of limited because all of your audio clips would load, or they would be, you'd have to set them to streaming, which has its own problems. So now you can go in and really write your own zone-based audio clip loading, data loading, things like that, which is really awesome. And yeah, multi-edit audio clips. We have per platform importer overrides, as you saw. And we got rid of the 2D, 3D setting from the audio clip, which didn't really make sense. I don't know if you guys ever thought about that, but it's kind of weird that you would set the 2D or 3D settings on the actual source data. So now what we do is we put it on the audio source, and we don't actually even have a toggle for it. We just have one slider called Spatial Blend, which allows you to go from fully 2D to fully 3D, or some sort of interpolation between the two. And we also have allow you to do set the reverb zone mix, and we've just cleaned up the inspector for the audio source a lot. So yeah, thanks very much for coming. Skål is what you say in Denmark, which is for cheers. So if you have any questions or anything like that, I welcome you to hit me up. Thanks for listening.
Since Unity's been using it for a while now, where do you see the role of sound designer? Because these use the Plus Studio.
Yes.
Now you're putting more control inside Unity, which is good to be able to see spatial relationships and stuff.
Yes.
And states.
Yes.
But like, you see people moving across to work inside Unity rather than Plus Studio.
I guess like the Wise plugin and the Fmod Studio plugin and things like that, they're really cool. And I think like there's going to be people that are going to want to use those tools no matter what, and we'll obviously make it flexible enough that you can shut down the audio system in Unity and use those plugins. But at Unity, we feel that we could probably give you a much more tighter experience, something where, like I said, you can jump into play mode. You can actually construct your audio scene as you're playing the game, creating assets, creating and sort of iterating, mastering the mix while you're actually playing the game, which is like super awesome and super important to be able to sort of tweak the mix quickly instead of having to go do some authoring, build, make it come across, import it, those sorts of cycles. So yeah, so I guess like we want to give you guys a really awesome integrated experience. So we're going to continue to create our own tools. We're going to keep fleshing out the audio mixer, and as you saw before, with a director thing in the keynote. So I don't know if you saw that there was a lot of audio clips there. So we're actually pushing a lot to create a system where you can do interactive sounds that will integrate very heavily with other subsystems as well. So you can do things like integrate your animation with your sound playback. If you've got some IK events that you want to play a sound on, those sorts of things, you can just visual script or whatever. So that's kind of where we're heading. This is our goal, I guess, our future. I guess, yeah. The thing with the director is super exciting and something we're working on pretty heavily. You can imagine, I guess, a situation where you'll be able to create a new sort of visual scripting situation. You want to create a kind of an ambience where it's a bunch of wind clips that just randomly play. So you just drag those clips in. You drag in a spawner node, you connect them up, and it's just starting to spawn random clips. But then you can take that even further. Maybe you have a particle system that you want to drive what's happening in the particle system with actually the audio signal. So then from the spawner node, you actually connect it up to a meter. That parameter, you connect to a parameter in the particle system, and actually the wind, as it's increasing, the particle system like blows more smoke or something like that. So I mean, this is where we're going in the future, and this is like this tight integration is something that we can only really give to you guys if we do it in Unity. So,
sounds really cool. Just one other quick question.
Yeah.
I'm really interested in sound with VR. So have you looked at HRTF?
yes.
And also with real space 3D profiles, just what's happening there?
Yeah, so that's something that we're working on as well heavily. We're talking with the guys at Oculus, the guys at Dolby, the guys at Valve as well, because they're interested in VR as well. And this is something that we're going to be working on in the future. So proper HRTFs, and also physically based sound. Like characteristics, like reverb and things like that, that we're kind of looking into now.
So has that just started, or?
Yeah, it's an ongoing process. No, I'm not sure. I can't tell. Yeah, next. Yep.
Are we going to be able to run microphones or line-in signals into the mixer as well?
Yeah, actually, I wanted to actually do a demo. Basically, I've got this demo where I have the mic feeding into the mixer, and then I like transition between different like sounds, like whether it sounds like a telephone or like you sound like a demon or something, like by doing like a reverse impulse response. But the problem is I get wicked feedback, and it just I can't do it here. But there's a video online of me recording the whole video through Unity, so yeah, you can do it. It's on YouTube somewhere. It's on the Unity channel, I guess. Just search for my name. I think it's in the title. Yeah.
Any idea what latencies are like across the different platforms?
Okay, so I guess the latencies being worked on. One of the biggest platform problems we have is with iOS. Sorry, not iOS. Android. Yeah. And we're working with Google heavily now and this is especially important for VR as well, because latency is in audio and VR makes it even worse. So yeah, we're working with Google to reduce the latency a lot. So basically, we're transitioning away from audio track and going to OpenSL, and basically querying the device for the buffer lengths and the sample rates, and if we set Unity to the same ones, we get onto this thing called the fast path, which means that latencies drop from like around 200 milliseconds to 10 to 20 milliseconds. So yeah.
Does that bypass the kernel?
Yeah, it bypasses inside Android all of the extra buffering.
It's a native bridge layer, so you don't cut through Java. It's really fast.
Yeah. And it also bypasses all of they have all these buffers for like their own internal effect processing and blah blah blah. It just gets rid of all of that. So yeah. Yeah.
You might have already mentioned this, but when you were talking about the plugin side of the VSPs, do you expect to see a lot of VST style put together out of that? Can you control the visuals of the whole?
Right. So with VST, yeah, and in general. So I guess like we didn't do a VST plugin off the bat because VST is not cross-platform as much as, I mean, we're like on 16 platforms or something. And it's only on a bunch of them. So it didn't make sense to make a VST like a native thing. But sure, you can easily write a plugin. I'm working on a plugin now that allows you to route audio out of Unity into pure data, do some processing, and then back as it's playing along. Or you can do that with Ableton or whatever. So it's actually in the effect deck here. This is teleport demo, and this is all these demo effects will also be distributed with 5.0. So it'll give you like an idea of exactly how to teleport it into another application, process it, and then send it back, or do generating in another application or whatever. Because yeah, you can see here we have like synthesizers and stuff as examples. Yep.
The Opus codec and/or custom codec support.
Yes.
Opus is the new codec designed for us to enable us to make faster performance. It's smaller for higher quality audio.
Yes.
Are you planning to integrate A, B? Can we
That's a good question. At the moment, you won't be able to write your own codec plugins, something we've really considered as well. But yeah, we also have considered Opus in anyway. We've taken a look at it. It seems pretty cool, and if we get a chance, we'll try and put it in. And as you saw with the importer, it should just mean just popping up as another option to choose from in compression. So hopefully it'll be super easy. Yeah, I'll check in before. Yep, go.
Hi. So in regards to game developers, for sound effects and that kind of stuff, what is the most sort of thing that people are looking for? Because, you know, if you go into the asset store and so on,
Yeah.
I might be able to produce sound effects and all that.
Yes.
To my contacts. What are the most sort of in-demand things that people need
Um,
from your experience?
I guess things like reverb, a decent reverb, is something that's, I guess, missing, which is also difficult to do because it's somewhat CPU intensive if you do it correctly. As you saw, we had this example impulse response DSP, and it's pretty cool, but there's probably better ways of doing it.
But actually, I also meant things like, is it footsteps, gunshots, that kind of stuff?
Oh, okay. Yeah, I'm not sure. You'd have to, I guess, yeah. With actual stems, I'm not sure. You'd best like check on the asset store and yeah, I think so. Yeah.
Is the custom DSPs cross-platform?
Yes. Well, I guess cross-platform. If you compile it on, the DLL to different platforms,
Is there any web targets?
No, unfortunately.
Is this all in the 5
Yeah, it's all ready to go. I think the only thing that's missing is the audio clip overrides because we've just finished that off, but that's going to be coming in soon. Yeah. Yeah.
Will you be able to stream, data path asset loading, as in like put MP3s into a folder, like allow the user to play their own music? At the moment, to write something like that, you have to write a very customized piece of script to get that going.
All right. So you're saying like yeah.
It's a workaround at the moment. Is that going to be natively supported?
That's a good question. I guess we could probably improve that. The only thing at this moment, like obviously the asset pipeline is very configured to assembling the data exactly how we like it. But yeah, it's a good suggestion. So you're looking for something that you can just drop in sources and then...
People have tried to do it, and there's workarounds that currently do it, but you have to create your own asset data, or like create your own audio sources at runtime. And it's really difficult to pull off. But yeah, the whole idea is that, like, say the user just has a folder, and they can just populate it with 10 songs, their own MP3s, and they can play it in game.
Yeah, okay. I'll definitely consider that.
Really simple.
Yeah, for sure. Yep, anyone else? Yeah, at the back. Multiple listeners. I guess like, yeah, we're definitely trying to figure out how to do multiple listens correctly. I guess the main problem is kind of, the thing with multiple listeners is that you start getting to relativity issues. Like if I have 2 listeners and then I have a sound source that's moving along and it's like one listener is hearing it like Doppler affected, the other one's not, and then so there's different like situations. I guess you need to just cut that all out. I mean, the way it's usually done is that you just remove all the Doppler, and you basically just trying to get the closest source to the closest the sort of listener. And we can do that, I guess. But it's something that we're trying to consider better solutions or better ways of doing it. But we're definitely like working on it. Yeah, exactly. Yeah, exactly. Yeah. Yeah. You can still drop trackers into Unity and they'll still play. Oh, okay. No, at the moment it's just considered one source, so it'll just, yeah. Still, yeah. Actually, that's an interesting point. Yeah. Okay.
And also the speed would be also when you can control the speed. It's like an e-file, it will have to pitch down.
Right.
So I know Unity pre-reads and stuff. So those are two things that would be GIS and mobile.
Right. Okay. Cool. Yeah, I'll take that on board. Yep. Anyone else? Awesome. Oh yeah. Here.
Can the mixer handle more gradual transitions than the example?
Oh yeah. So I mean at the moment the example that I showed was I think it was 0.5 seconds. So yeah, basically when you transition, you just specify the time period, the time length that you want to take to transition over, and it'll just transition slowly. I didn't talk about this actually in the talk because there's a bunch of stuff that it would have taken up too much time. But basically, you can actually choose to, for any parameter within the game, you can expose it. You can take in full control of that parameter from script if you want to, any of the parameters within the audio mixer. Secondly, you can actually override how it transitions. So the default is linear transition between snapshot X and Y, but you can change it to like brick wall at the start or the finish, which means that you can. If for things that don't make sense to transition slowly, you can just like have it happen start, finish, or whatever. And also, yes, you can do something else. I forgot what I was going to say. But yeah, there's a lot of sort of hidden extra functionality that you can do to sort of change the way it's sort of. Oh yeah, actually, that's what I was going to say. Not only can you just transition from one snapshot to another, but you can set up weighted blends of like a whole bunch of snapshots. So if you have like a bunch of zones that all intersect, you can just have like weighted blends of all the snapshots at once. So.
What about beat matching for transitioning music?
Beat matching, yeah. This is something that we're going to be working on, like in the director thing. So we want to create a system where you'll be able to do sort of very sample accurate. Beat matched kind of assembling of audio, and this is something that we're going to do for in sort of the 5x release cycle. Anyone else? Okay, thanks very much, guys. I really appreciate it.